Hello students, welcome to the series of vector calculus. In this video I am going to discuss the concept of curl, and this is a part 1 of this topic named as curl. So if I will talk about this topic curl, actually it is what? Curl is applicable upon a vector field. Curl is applicable upon a vector field and its outcome is also a vector field. So what I want to say here, I want to say, like, if I will apply curl upon a vector, so a vector point function will be obtained. So a vector point function will be obtained, or we may write it like, we will apply curl upon a vector point function. We will apply curl upon a vector point function and the outcome will also be a vector point function. The outcome will also be a vector point function. Now the question is like, how to define the curl. So suppose v vector is given like v1 I cap plus v2 j cap plus v3 k cap. So this is a vector point function. So how the formula of curl of a vector point function is given? It is defined as del cross v vector, where del is operator defined as I cap partial by partial x plus j cap partial by partial y plus k cap partial by partial z, and v vector is given like v1 I plus v2 j plus v3 k cap. So how I may write it? I may write it like I cap partial by partial x plus j cap partial by partial y plus k cap partial by partial z cross product with this v1 I cap plus v2 j cap plus v3 k cap. Now what is the next step of this definition? The next step of this definition is like, it is formed as a determinant. In first row I cap, j cap, k cap will be provided. In the second row these coefficients will be provided: partial by partial x, partial by partial y, partial by partial z. And in the third row these coefficients will be provided like v1, v2, v3, and it is equated to curl of v vector. I can also modify this particular determinant as per the next step. So how I can modify it? Like I cap, then determinant of partial by partial y, partial by partial z of this v2 v3 minus j cap. It would be like partial by partial x, partial by partial z v1 and v3 plus k cap, again determinant of this one, partial by partial x, partial by partial y v1 and v2. So here all the v1, v2 and v3 are written in small letters. along with the subscripts 1, 2 and 3. Now little bit more modification can be done here. I cap partial v3 by partial y minus partial v2 by partial z minus j cap. Inside the bracket I can write it partial v3 by partial x minus partial v1 by partial z plus k cap. Inside the bracket I can write partial v2 by partial x minus partial v1 by partial y. Or finally this curl of v vector is defined as partial v3 by partial y minus partial v2 by partial z I cap minus partial v3 by partial x minus partial v1 by partial z of j cap plus partial v2 by partial x minus partial v1 by partial y of k cap. So in order to evaluate the curl of any vector point function, we may utilize this formula directly also. Now one question would be discussed here in order to create a better understanding of this topic. So question is like, find the curl of position vector. Find the curl of position vector. So what is the meaning of position vector? That is r vector, and it is defined as xi plus yj plus zk. I mean to say xi cap plus yj cap plus zk cap. Question is like, what is our aim? Our aim is to get here curl of r vector. So it means del cross r vector. So again I may write it like I cap partial by partial x plus j cap partial by partial y plus k cap partial by partial z. Cross product with this r vector. R vector is xi cap plus yj cap plus zk cap, and in the determinant form it may be written as I cap, j cap, k cap, and then these coefficients partial by partial x, partial by partial y, partial by partial z, and in the next row these coefficients x, y and z. So I have started from scratch in this answer so that the whole detail can be recalled again. So I can write it like I cap of partial by partial y, determinant of, I mean to say partial by partial z, y, z, minus j cap, determinant of partial by partial x, partial by partial z of x and z in the second row. I mean to say in the first row partial by partial x, partial by partial z, and in second row this is only x and only z. Then the third term is like k cap. So it is partial by partial x, partial by partial y, x and y. So now we may easily evaluate these terms, that is I cap. So it is partial by partial y of z minus partial by partial z of y minus j cap. So inside the bracket it is partial by partial z, actually not partial z, it is partial by partial x, partial by partial x of z minus partial by partial z of x. So what is this? Partial by partial x of z minus partial by partial z of x plus k cap. Inside the bracket it is partial by partial x of y minus partial by partial y of x. And as per the definition or concept of partial derivative, all of us know that with respect to y, partial differentiation of z is 0, minus with respect to z, partial differentiation of y is 0, minus j cap. Partial derivative with respect to x of z is 0, minus partial derivative with respect to z of x is 0, plus k cap. It is just like I will say partial derivative with respect to x of y is 0, minus partial derivative with respect to y of x is also 0. Ultimately, we will be getting here 0 I cap plus 0 j cap plus 0 k cap, and this is equated as curl of R vector. It is equated as curl of R vector. So what I want to say here, it is curl of R vector is equal to 0 vector. It is equal to 0 vector. It is very important concept here, because we cannot write 0 here only. As I told you that we apply curl upon a vector point function and the outcome is also a vector point function. That is why when we will apply curl upon this position vector, actually it is a vector point function. It is a vector point function, then outcome should also be vector point function. It should also be a vector point function. Vector point function. That is why our final answer is that curl of R vector is equal to 0 vector. So this was all about the curl of position vector. In the similar way, this particular concept, this curl of v vector, I mean to say this particular concept, this formula which is equated to this particular formula, and finally which is equated to this determinant formula, any of these formula can be applied in order to find the curl, or this updated formula may also be applicable in order to find the curl of a vector point function. So students, I hope this video will help you a lot in order to understand the concept of curl of a vector point function. Thank you so much for watching this video.